they would solve. So let's take a few of these. I'll draw a few analogies to help you out. If anything you can do, you can always think about how you're writing your work. After you've improved mathematically as much as you can, how you write your work down, how neat it is, can make the difference. If you write bigger, maybe you can see negatives more clearly so you don't miss negative stuff like that. That's not really mathematical, it's just how well and neat you write things down can affect whether you get things right or wrong. So let me draw a comparison here. This is what you guys did on your quiz that you just got back. You had numbers on both sides, right? This just has variables on both sides. This has numbers on both sides with one variable. This has variables on both sides with one number. So they're very similar, except for one little thing. So it's always smart to look at a problem that's similar that you already know how to solve. Like if we already know how to do this, oh yeah, I put the variables on one side and I canceled out the number on this side. So that at the end I had variables on one side and the numbers on the other side. Well, that will work just fine here as well. It's just instead of adding and subtracting a number, you add and subtract the variable. Okay. Show the algebra, show something canceling out. Line everything up as vertically as possible. So right above it, I can see exactly where 5u came from. It came from 8 minus 3. Equal signs are lined up. Leave a space where it's canceled out and drop to 35 straight down. And of course, do not do this. Some people did this on the quiz, and you saw there was a -1 there because you did not prove it. Well, where did 7 come from? Well, right above it should be the evidence on where 7 came from. Right? So that's why you got to put divide by 5 on both sides. Where did the 7 come from? Right above it, 35 divided by 5. Very clear. We can understand it. We can follow your work perfectly. But without that, it doesn't make sense, right? Even if you know it, still got to write it down. So this is the algebra. This is the class you're in. So you, yes, must write this all the time. What you did to both sides to get the answer. Think about it as, court cases and whatnot. How often do you see court cases that are talking about free speech? Right? Probably heard of a lot of things about free speech. Free speech was around since 1786, Bill of Rights, right? But a lawyer can't just say, like, well, everybody knows Bill of Rights and free speech. I don't have to tell you that. Like, they still have to say that in the courtroom and bring it out. Even though it's kind of obvious to everyone, you still have to write it down and show it. Okay? Just as a matter of fact, not because we all need to see it to understand it necessarily. For the first column, the left-hand column, please do a check. So for all of these, just like you did in your quiz, on the left-hand column, plug it back in and prove your answer correct. And this is why I had you guys do this on the quiz, so you get higher grades. Now you have to do these independently. So you never add, subtract to both sides when you're doing a check. You just simplify the left and simplify the right. And they should end up matching if you did it right. If they don't match, that means something's wrong and you go back and recalculate. Saw a few people that kind of did some funny things on the quiz. If they had like 1 equals 1/3 plus 3, or plus 8 over 3, and then right below it they write for 1 equals 1, and they put a check and say, see, it's right. Like, well, this does not equal this. 1/3 plus 8/3 does not equal 1. You can't just jump to it and say, well, I know in the end I want these to be the same, so I'll just write them as the same. It doesn't work. You have to make sure these actually add up to what's right above it. Okay? So that would not work as a check. Right. First column, please do a check. Let's see here. Let's do one more. I. It's okay if they're out of order because there's really no order to all these letters anyway. Recall that it might be useful, just might be useful to put a 1 right here in front of the K. Don't have to, but it might be useful. So that when you do the algebra, it's a little more clear exactly what you need to do. So K minus 8K is the same as 1 minus 8, right? 1 minus 8. get 1 minus 8, which is -7. So -7 times what is going to equal 28. Leave a little space for where the variables canceled out. And that space lets you know later on when you look at it. Well, that's because something canceled out right there. Very easy to go back and understand. And of course, show the division. I'll let you guys do the check and prove that to be true. Now, you've probably noticed that the first 6 are different from the rest, right? How are they different? The first 6 problems compared to all the others after that. One thing, yeah?
The variables only on one side.
Close. The numbers only on one side. All right, so all these have variables on both sides, but then all of a sudden when you get to H, you got variables and numbers on both sides. So we're going to put together what you already knew how to do, combine what we did in the first 6 problems, and handle variables and numbers on both sides. It's just a culmination or a combination of what you've already done before to solve these other ones. All right, so let's look at H. Go ahead and write H down. And just like before, we always want to get variables on one side and numbers on the other side, right? It doesn't have to be left side variables always and right side variable numbers always. You can go either way with it. Now here's what I suggest you do. For your algebra, do the steps together. So do 2 steps of algebra simultaneously, like this. If we want the variables to be on the left, like if I want this 2 to be over here with a 4, so I'm going to write minus 2x, because this is positive 2, right? So I'm going to subtract. But also do the number algebra as well at the same time. So I want the 4 to be on this side, right? So I'm going to get rid of positive 4 by subtracting 4. So you see how I have 2 colors up here? There's 2 steps of algebra combined. This is a good idea. Usually I wouldn't say you rush through and do 2 things at once, but by doing this, it actually lines up variables with variables and numbers with numbers quite nice. And you don't accidentally put a minus 4 underneath 2x or something. Keeps everybody grouped properly. So 4 minus 2x, 2 times what? Leave some space, equal sign straight down. And 36 minus 4 is 36. So we have 1 and 2 steps here for algebra. And then a 3rd step with dividing by 2 on both sides. So 3 steps of algebra to show here. So 3 cancellations. You might notice this, every step of algebra has a cancellation. Whether it equals 0 when you're adding, subtracting, or equals 1 when you're dividing. And of course, this is the left column still, so yes, prove your answer. Takes a little longer, but a little longer, we're talking about 5 seconds longer. Still worthwhile to go through and make sure you're actually getting the right answer for the sake of quizzes and tests. So 68 equals 68. Because these actually add up to 68 in their own way. Not because at the end I just want to put the same number so I can write a check and say, look, I'm done. So independently, I'm not adding, subtracting to both sides on the check. I just add up the left order of operations, add up the right order of operations, and they should come out to be the same. If they don't come out to be the same, that means your answer is wrong. You go back and you find a mistake. It's usually a negative. All right. Maybe one more. To, how about M? All right. So I'm going to do this left column. So I'm going to do this a little different. So I got the variables on the left, numbers on the right this time. Here, it's probably a little easier if you put the numbers on the left and the variables on the right. How can I tell that it's easier if I do it this way? Now, if I start subtracting 2x on both sides, I'll have negative. If I start subtracting 63 on both sides, I'll have negative. But if I reverse that and I add x to both sides instead, and I subtract 3 on both sides instead, you can see how I'm left with numbers on the left, right, 60, positive. And on the right-hand side, I'm left with 1 plus 2, which is 3, positive. So by switching it around and putting the numbers on the left on this one, it keeps all the numbers positive, which, 99% of mistakes are negatives. That's a good thing to not have negatives. It wouldn't be wrong if you did it the other way. You'll still get the same answer. But if you can avoid a risk without doing any extra work, why not? Keep it simple. And this is on the right column, so we don't need to check this. So try out both. Try doing the numbers on the left, variables on the right, and also vice versa, variables on the left, numbers on the right. Kudos if you can do each problem both ways and show that you get the same answer regardless. Right? So, of course, when you guys are checking each other's work tomorrow, just know that it may not match yours exactly because they did it a different way, but you still get the same answer. Algebra is different, answer's the same. All right, so I'll leave you guys to work the rest of the period. We've got plenty of time. You should be able to finish most of this, if not all of it, if you work the whole time. So stay focused, ask questions as you need it, and you'll get finished for sure.